bandwidth issues. So I'm trying. Hi. You have A, B, C, D, and E. I'll be. Great. I think we're picking back up. Should be coming back soon. Yeah, I think we're back. I think we're good. All right, we're back. Hello, hello, hello. Everyone can hear me now, right? Should be back to good territory. Nice and HD back, right? You know, if I'm not a teacher, I should probably be like a tech support or something. You know? All right. So here we go. So part A, they're asking you to find Sn. Okay, Sn is the sum, right? The sum. This is a geometric series, right? So remember the sum formula was what? G1 times 1 minus r to the n over 1 minus r. Right? Remember this? This was our formula, right? For sum of geometric series. Right? Then, so because of that, we just plug in the terms then, right? So A would be, so G1 first term is 1. 1 minus R is what? 2? 2 to the n over 1 minus 2. So 1 minus 2 is negative 1. So it'll be 1 minus 2 to the n over negative 1, which is actually 2 to the n minus 1, because you flip it. Right? So this is number 1. Okay. Now, then you can find any term you want, right? B would be 20th term, so S20 would be 2 to the 20 minus 1. All right? You don't have to simplify it, okay? It takes too long. Or too many terms. Too many numbers, right? Too many digits. Okay, S100, same thing. As for 1,000, same thing. Now, what is happening? How is it getting bigger or smaller? What is this? 2 to the 20th. Let me give you a sense. Is it getting bigger or smaller? Because they're asking you infinite terms, right? What happens in the end? You keep adding things. So 2 to the 20 minus 1 was about 1 million. Around 1 million. Okay. This is around 1.26 times 10 to the 30th power, which means 1 and then 30 zeros afterwards. Okay, 1 and then 30 zeros. 30 places after that, because it's 126 and then 28 zeros, right? And then if you do 1,000, it says overflow, which means too big. Okay. All right. So now look at this. So what will happen if it's infinite terms? What do you think it's gonna be? If this is already too big, then this is even bigger, right? So we will say this should go to infinity. Now, how do I notate it? When I write limit of what? 2 to the m minus 1, right? That was my formula. N goes to infinity. Okay, like that. This is equal to infinity. Okay? Or goes to infinity. We're okay so far? So introduce back to the limits stuff and combine with the series formula we learned before. What is this saying? It says, hey, if I add from 1 and 2 and 4 and then 8, I keep adding by something multiplied by 2, right? Geometric ratio is 2, that's why I put 2 here. If I keep adding and adding, I should get bigger and bigger and bigger, and there's no bounds to this. If I keep adding, I'll keep getting bigger indefinitely, so I'll approach infinity in the end. Okay? Does this concept resonate with you? Does it make sense? Alright. Okay. So, next part. 3 plus 1/3. Does this have a pattern? I feel like this is messed up. What's the pattern? I don't see anything. Do you see it? I don't see anything. Oh, I know why. This is supposed to be 1. Okay, you can't do it with 3. Change this to 1, otherwise you can't do this. Okay, change to 1. Change to 1. This is a typo. I'm looking at the notes right now. It's a typo. Okay. So, can you try this real quick? Really quickly? Try this. See if you get something. So when you write it, it should still be the same way, right? I'll stop saying stuff, and then you just, when you are done, you can look up. Okay, see if you get the same thing. Alright, so first of all, my Sn should look like this. It's the same thing except the bottom one is positive this time because it's 1 minus 1/3, right? So it's positive 2/3. And then you flip it, you'd be 3/2. Okay? Then B, you want a 20th term, so you plug in the 20th term, right? You don't even have to simplify, okay? Plug in the 20th term. And then part C, you plug in the, this is S20, right? And the next one's S100, right? So we just plug in 100 into the equation. You don't have to simplify, okay? Too many terms. Oh, 3/2. Okay. Okay. All right. So finally, let's look at the main thing, which is when n goes to infinity. So part E, we're looking at n goes to infinity of 3/2, 1 minus 1/3 to the n power. Now, the only thing that has n here is this part. Right? This part has n. What happens when this goes to infinity? When n goes to infinity, what will this become? If you multiply by 1/3 over and over and over again, what does it become? What do you have? You multiply by 1/3 over and over again. What will happen? Type. What will happen to this part? 1/3 to the n power if n is big. So 1/3 times 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 1/3. What will happen? What will happen? Just type what you think. It doesn't have to be correct. Approaches 0, Sani said. And Sally. So this part should go to 0, right? So you can treat this as 0. So what do I have left? I have 3/2 times 1 minus 0, which is 3/2. Okay? Alright. So if you plug these into a calculator, they should be very, very close to 3/2 and getting closer, right? Hey, alright. We have some issues here. Hey, two things. First thing, that means even if you keep adding something, eventually you're going to get a number for this case. Unlike the first case we had, which goes to infinity. So in other words, this converges to 3/2, this diverges infinity. So why does one infinite geometric series converge, the other diverge? Why? So what will determine when an infinite geometric series converge or diverge? Let's take a bigger look. So 1 and 2, what is the main difference? Why does one go to infinity, the other one remains 3/2? How come? Type in the chat to see what you think. And once you type it in, you write it down here as well. What is the main difference between 1 and 2? Why does one go to 0, the other one, why does one go to the number, the other one doesn't? How do you make the distinction? What is the main difference? Look at it. Type it in. What is the main difference? So what is greater or less than 1? Are you talking about how the number changes? So look at how it works. This one gets bigger at 1, 2, 4, 8. This one, 1, 1/3, 1/9, etc. What is the main difference? So Sagan pretty much said it, but she didn't say it very specifically. So greater or smaller than 1, what? Greater than smaller than 1. Well, if you want to be bigger in a geometric sequence or series, you have to be ratio bigger than 1, right? And this one ratio is smaller than 1, so when r is greater than 1, or absolute value of r, then let's put Sn diverges. If r greater than or equal to 1, actually. No. Yeah, greater than or equal to 1. Less than 1, Sn converges. Okay? Why all also equal to? Equal to meaning you're adding the same thing over and over again, right? So in the sequence sense, it converges, but in the series, remember you're adding, right? You're adding 1 over and over again. There's no stopping it, okay? You have to keep adding 1, or adding 2, or keep adding 3. Then it keeps going up, right? Now, let's go back down and see how it converges. So they give you a series. Now let's take a look at how they come up with the solution. So you know how your formula was, they put T1 as term 1, so I'll follow their notation so you can see which one is which. So this was my original, right? My original formula. When n goes to infinity, when this happens, this part becomes 0, right? We talked about how when r is less than 1, when r is less than 1, absolute value of r is less than 1, that means this part will approach to 0. Then that means the whole thing will end up being just t1 times 1. So it's t1 over 1 minus r. Okay, that's how they come up with this. Okay, it's because this part. Then if r is greater than 1, then it obviously diverges. Okay, keeps getting bigger. This is a very interesting concept if you think about it. Okay, and it kind of doesn't make sense intuitively. So let me give you an example. Okay, so why does such thing converge other than mathematically it makes sense? So let's talk about something. Okay, let's talk about an example. Okay, so this is a person, this is another person, right? So let's just say our distance between is 2. Okay, 2, let's just say yards. Okay, 2 yards. Now let's just say that this person wants to walk towards that person. Okay, but every time I'm only walking half of what is left. Okay, half. So walking half of what is left. So I'm going to walk more and more each time. Not walking less each time, but the total of my walking is more, right? So first time I walk, I will be here in the middle, right? Walking towards that person, I'll be in the middle. Next time I'll have 1 yard left, so I'll walk here, right? Half a yard, and then 1/4 a yard, and then 1/8 a yard, and then 1/16 a yard. I'll keep walking towards the person, but I will never actually reach this person. Okay? I'll keep going. One day I will get 2 yards. Okay, so the sum will look like this. 1 plus 1/2 plus 1/4 plus 1/8 plus 116 plus blah 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 blah. Even though I keep walking, I will never actually reach here until the end of the days, which is infinity. Why? So if you look at the mathematical standpoint, it would be S infinity equals first term over, so right, T1 over 1 minus R, right? So it would be T1 first term, 1 minus R is 1/2, so that would be 2. Like that. Pull it forward a little bit. Okay, so that's the idea of infinite geometric series. Give me a comfort level 1 to 10. Let me see how much you grasp this. Six? Eight? Six, eight, 6, 8. Alright, not bad. 7. Okay. Alright, so let's take a look at this. How about you do, let's do one more example. Okay, let's do one more example. So if you look at this, what is the ratio? Can you, oh, first of all, what is the first term? Term 1. That's the first one, right? What is the ratio? Tell me the ratio. What is the ratio here? What is the ratio? What is the ratio? Negative 1/2. Right? So, because I know sum is first term over 1 minus R, right? So, first term over 1 minus negative half. So, that'll give me 1 over 3/2, which is 2/3. Okay? 2/3. Okay, so let's go ahead and look at number. So 4 and 5 you can do at home. Okay, number 6. Okay, number 6. Find the interval of convergence. Find the sum in terms of x. Okay, So this part, so what is interval of convergence? So you see this x, right? So can you tell me what the ratio is right now? What's the ratio? What is it multiplying by? So obviously first term is 1, right? What's the ratio here? What is the ratio here? 3x, right? Because you multiply by 3x each time, right? 1 times 3x is 3x, 3x times 3x is 9x squared. So ratio is 3x. Okay? Now, because there's a variable here, remember your formula, right, only works if it's convergence, which means that you're getting smaller each time when you're doing the ratio, right? So what is the ratio? Right? What is the ratio? 3x. So what does it have to be in order for it to converge? That's called interval of convergence. Okay? So my ratio, right, needs to be less than 1. So in other words, my 3x needs to be less than 1. Right? 3x is less than 1. That means what? 3x is in between -1 and 1. Right? You can combine these like this, or you can solve them separately. Either way, just take out absolute values, should look like this. Divide by 3. So that means x has to be in between -1/3 and 1/3. This is called interval of convergence. Okay? Why is it called interval of convergence? Because that's the interval it converges. Right? Like x has to be in between -1/3 for 1/3 in order for 3x to be less than 1, in order for the series to converge to a number. Once we get that condition done, that's part A. Okay, part B, then you can find the sum, right? T1 over 1 minus r, right? Because this is infinite series. Infinite series, the top becomes just this. So that would be 1 over 1 minus 3x. Okay, that's it. How are we doing? Any main questions? Alright, let's look at number 7. Read it once. Once you read it, give me a comfort level of number 7. You have an idea of what it's talking about, and write down the known values that you have. Okay? So I'll give you 1 minute. Write down what you know and give me a number to see like how much you feel about how good you feel about this problem. Okay? 10 being like this is it's completely makes sense to you. I know what to look for. 1 being I have no idea where to start. Okay? Read it first, give me 1 to 10, and then write down your givens. I want to get a number 7 from Sally. Anybody else want to give me a comfort level from this problem? Seven. So 7 meaning like you have some idea, but you're not sure if that goes anywhere. Is that what it feels like? Like you have an idea which direction it should go, but you're not sure if that actually nails the result. So let's try to write down some stuff. Okay, so first 3 terms of an infinite geometric sequence, a sum of 16, right? So if you think about sum of 16, okay, let's see. So first term, so sum, right? Sum is 16. What is sum? Isn't it sum this, right? T1 over 1 minus R, or G1 over 1 minus R, or A1 over 1 minus R. Whatever first term you use, right? They didn't tell you what first term is, right? They tell you what the ratio is, which is this, right? This is supposed to equal 16, right? No? So can you now find what T1 is? Alright, so what do we have? This is T1 over 3 halves is equal to 16, right? So you multiply this over. T1 is equal to 16 times 3 halves, which is 24, right? And then so once you get that 24, that's your first term, right? So it will be 24, right? And the next one would be what? Times, what's the ratio again? Negative half, right? So that times negative half, that has to be negative 12, right? The next one will be positive 6, and the next one will be negative 3, because your ratio is going to be negative 1/2, okay? And then you keep going, and the answer to the sum is 16, basically. Okay. Is that okay? So knowing from the information they give you, that's what I get. Okay. How are we doing? Alright, so if you are okay, flip it over. So circle this one. This one is a very interesting sum. So write homework. This is for you to explore on your own. I'll talk about it if you don't get it, okay? But before that, 4 and 5 is also homework, okay? 4 and 5 also homework. If you haven't done it yet, these 2 are homework problems, okay? So, number 2, homework problem. All right. Number 3 is what I want to talk about first. I'll talk about partially, and you can finish that as homework, okay? So, there are several things I want to tell you, okay? I want to remind you of, okay, on this one, because it has imaginary number I, which is like your favorite, right? So, let's take a look at how the term goes, okay? So, can you first tell me, because this is they want to find the end term, which is this term, right? So you have to find out some sort of pattern, okay? So what is the pattern here? What are you doing? What is happening? So let me just tell you, it's a geometric, right? So what is the ratio? Tell me, what is the ratio? What are you multiplying by? Well, if I already tell you it's geometric, right? You know this times an R, right? I times an r is -2, right? So that means r equals -2 over I, okay? And because we are good with like rationalizing, right? Or realizing. So this, you multiply by I top and bottom, remember this, -2i over I square. I times I, remember I is square root of -1, right? So to square that, it would get -1. So this will be 2i, okay? 2i. Now this is my ratio, right? Does this converge or does this diverge? Okay, that's part C. We'll answer that in a bit, okay? So first of all, A, this is geometric, right? So your n term would be, remember the n term? The n term, not the sum of n term, it's the n term. Remember gn equals g1 times r to the n minus 1? Right, they want tn, right? So tn, gn is tn. Okay, first term is I, r is 2i to the n minus 1. Okay? So if everything is the same except my r is in I. That's why all my imaginary number will make the C series. Okay? And they want the n term. They don't want the sum to the n, right? So they just want the n term. I give them the geometric n term. Find the first sum of the first 9 terms. Okay? This is 9 terms, right? Not infinite terms. Sum, right? So Sn, or S9 in this case. So remember your formula for S9 would be T1, I'll write the formula first, 1 minus r to the 9th over 1 minus r, right? This is the n power. First term is I, right? 1 minus r is going to be 2i to the 9th power, all over 1 minus 2i. Okay. You can keep it like this. I don't need you to simplify this, okay? Just keep it like this. If you really want to simplify, you can simplify. Okay, do we want to simplify it? I don't want to. Alright, so keep it like this. If you want to, you can multiply this out. This will be, so if you multiply this out, right? Multiply everything out and distribute and simplify, this will give you, and rationalize everything. To rationalize, if I have to remind you, after you multiplied all this out, okay? To rationalize, what you need to do is multiply by the conjugate, if you remember. Okay, and do all the math, simplify, whatever. Eventually, you're going to get 510 plus 110 to 5i over 5, which will end up being 105. No, not 105, 102. Okay, 102 plus 205i. Okay, that's what you're going to get. Okay. Part C. All right. Does this converge or diverge? So that means you want to look for, does this, how does this work? Remember absolute value of an imaginary number. If you forget, here you go. There's a real and there's an imaginary number axis. I don't know if you remember this from Algebra 2 trig or Algebra 2. Or, I forgot if we talked about it in pre-calc. The absolute value of an imaginary number is the distance from it, right? This is 2i, right? This is in I, this is in real. It's distance from there to the 0 power. So in this case, the distance is 2. Okay? Distance is 2. Because of that, that is bigger than 1, right? Since it's bigger than 1, it diverges. Okay. But this one is a lot harder, it feels, because it has I in it. But if you look at it, they're all the same. If you follow the same pattern. Okay. So if you are still surviving, flip it over. I want you to take a look at this problem. Okay. So this is the last problem. This is going to be homework. So, okay, what you're looking for is you need to find the sum of this infinite series. Okay, that will be a number. Okay, we kind of talked about what this number is going to be. Okay, and you're taking a difference between this number and a finite series. You need to decide what does n have to be, at least that number, so that the difference between the sum is less than this. Okay, that is what you're looking for. Okay, so my suggestion is find S first, which is infinite. Okay, number 2, find Sn, which is whatever you use, right? T1, 1 minus r to the n over 1 minus r, this formula. Find that. Okay. You want to like plug it in, substitute, right? So S minus Sn, right? Set this up. You want to set it equal first. Equal, okay? Set it equal first. That way you can find the n value, okay? Find n. Once you find n, that means this is when it's equal. When it's more, anything bigger will work. Okay, so n will be you want to find the nearest whole number, okay? Whole number. Nearest whole number. Okay, so try that one. So in other words, your homework will just be the this. Well, I'll let you have some time to work on this right now. Let me set up your homework, and I have a few announcements to make. It has to do with our schedule and the rest of the year. And so stay tuned. Take a look at this problem first, okay? See if you get some sort of immediate questions that I need to answer before I let you go for a few days. I forgot to put the notes, the homework. any immediate questions for this question? So I've set up your homework. It's basically finishing everything we've done today. So starting from 13.5 part 1. So I put 4 pages on there, but we did most of these. The one that I haven't done is the one that I circle homework with, which are your duty to finish, right? It's due Sunday. Okay, so I already put on Google Classroom homework. Okay, please catch up your homework. Okay, so announcements. Keep carefully. Okay, announcement. Okay, number 1. So class will resume this Friday. This Friday is 22nd. And I think we're still using 1 p.m. because we're moving your long weekend Memorial Day from Monday to Friday. Basically, the schedule that you would have had for Memorial Day on the 25th is moved to this day, Friday. So basically, I think you already got this email, but that's the first announcement. Okay. Number 2, Chapter 11 tests soon. Yeah, I will. How do you, does it share something with your class? Is that what it is? Announcement. Class will, next class, next class is on April 22nd, Friday. 1 p.m. Okay, post this. All right, do you guys see the announcement? All right, Chapter 11 test will happen soon. Hopefully before next week. My guess is on the 29th. Okay. This is going to be more like an assessment. It's not going to greatly affect your grade, but it's a good idea to keep your progress, and it will somewhat affect your grade, but your grade is mostly, if you've been keeping up your homework, keeping up your attendance, then you should be passing the class. All right, there's no doubt, and this test will not affect that. Okay, but obviously, if you're like not doing your homework and blah blah blah, not keeping up, and obviously there's no guarantee. But if you've been keeping up your homework, if you've been attending class, then you should pass, no problem. So this test is not meant to stress you guys out. It's meant to serve as a assessment in terms of your learning progress, but it's not going to greatly impact your grade. But it doesn't mean that you shouldn't study, because this stuff is greatly impacting your calculus skills. So make sure you have this covered, okay? Final announcement. I won't put it up here. So obviously if you're a 12th grader, then you won't see me next year. But even if you're not, you will not see me around school, Mount Vista, next year. I am changing schools. It's some overstaffing issues here in the district, so they're moving me to Lynbrook High School. So yeah, Starting next year, I'll be in Limbrook. This is the first time I make the announcement, I think. Yeah. So I don't know when the next time that I'm gonna see you guys. I don't know. Let's say it's been fun, right? All right. So guess that's it. Anything else before I let you go? Logistic questions? Anything? Oh, thanks. It's okay. You guys will be good. To be honest, you guys are great. Oh, Karen, you're back. I mean, you guys weren't gonna get me anyways, right? I don't teach calculus. Although I will be teaching stats over there. So, for those of you who said that if I were teaching stats, I was, but just not here. So, for those of you who are taking stats, good luck to you. For those of you who are taking calculus, have fun. For those of you who aren't taking neither, have fun, right? Yeah, it's been fun. All right. Anything else? I mean, we'll see each other in a few days. So if you have any more questions about anything else, you can let me know, obviously, right? So, okay. All right. Since we're not lagging anymore, I can play a little bit of music, I guess. So, here it is. What's good music? What's this one? Whoa, that's way too loud. My goodness. Goodbye. Hopefully your earphone didn't explode. Bye-bye. Bye. Wait. Sorry. I think I looked at it wrong. It's chapter 12, guys. Wait, chapter 11? Nobody even, Chapter 12. This chapter, okay? This chapter. Sequences and series. Okay? what you're learning now. All right, what you're learning now and what you're learning before. So that everything we learn in remote learning. Yeah, chapter 13, 12 to 13 is together. And it's technically the same part. So it's basically, I just say chapter 12 and 13 together. But 13 is the extension of 12, basically. Okay? We just include the limit part. Okay? So it's basically everything we learn in remote learning. I should correct that. So thanks. So, yeah. I'll re-emphasize this on Friday. Okay? So, I mean, it's not like people have been studying super hard anyway, so like we should have enough time for that. Okay? Sequence and series, everything we learn sequence and series. Okay? Including the beginning until now. Alright? Alright. Anything else? Goodbye. Yeah, you too.